Hello everyone. For this video, we'll be talking about how I'll be showing you examples on how we would sketch graphs and also answering questions that ask for specifically two solutions. Okay, so let's look at this first example here. On the axis below, sketch the graph of y equals to the modulus of 2x squared minus 9x minus 5, showing the coordinates of the points where the graph meets the axes. Okay, in this case here, what I would do is I would first solve the quadratic equation for 2x squared minus 9x minus 5 using my calculator. I would have gotten x would equals to first 5 or negative 1 over 2. Okay, and from here I would mark it on my graph. Let's just say negative 1 over 2 would be somewhere here and 5 would be somewhere further around here. All right, these two are the points that when drawing this quadratic graph, which by the way is actually a smiley face, okay, since it's a positive quadratic graph, we'll cut the x-axis at these 2 points here. If it was a normal quadratic graph, it would look something like this. Okay, it looks something like this, where you have another point where it intercepts the y-axis at negative 5. But since it is a modulus graph, okay, it would be reflected off the x-axis. It will be reflected here. Okay, so the graph would instead look something like this. Okay, and then from here it would bounce. Okay, and intersect, instead of negative 5, it will intersect at 5. And continuing downwards here, and then bounce one more time. And this is how a modulus quadratic graph would look like. Okay, modulus quadratic graph. Now, looking at your next question here, find the values of k for which the modulus of the 2x squared minus 9x minus 5 graph that you just plotted is equals to k has exactly two solutions. When they say two solutions, looking at the note I wrote down here, solutions is when the line cuts the graph. Okay, in this case here, if you're looking for two solutions, now let me help you identify. The only point that first you can see that has two solutions is here, when your y is equals to 0 line. Okay, the second one where it would cut 2 onwards would be here. Everything above the tangent line where you have your supposedly minimum point. Okay, then from here we would have to find out the minimum point in this case. Okay, so there are two ways for you to be able to find the maximum point in this case here. First, you can either find the midpoint of these two roots, or you can use completing the square method, which I've shown you in the previous video. Let's say we do the completing the square method. Bring this out. Okay, x squared minus 9 over 2, x minus 5 over 2. Then complete the square for the inside, 9 over 4, bracket square, minus 9 over 4, square, minus 5 over 2. Okay, close bracket. Simplify your bracket from here, 2x minus 9 over 4 square, then 9 over 4 square, so minus 5 over 2 times 2. You would have gotten negative 15 and 1 over 8. Okay, negative 15 and 1 over 8. Now, this was supposed to be the original quadratic graph's minimum point, where it would have been 9 over 4, or in other words, 2 and 1 over 4, comma, negative 15, 1 over 8. Okay, but since it is the modulus, then we can assume that this value here has been turned into a positive. Okay, and therefore this line up here would have been when y equals to negative positive 15, 1 over 8. Okay. Now, as you can see, the line where y equals to 15, 1 over 8 still cuts the graph at 3 points. Okay. So, and that means that the values that are above 15 and 1 over 8 would be the points where they cut the graph 2 times, and therefore having 2 solutions. Okay. So for this case here, the answer for k is either when k is equals to 0. You see, when k equals to 0, then this is the line y equals to 0, or when k is more than the value of 15 and 1 over 8. Okay, make sense? Now, looking at the next question here, same thing. First, they're asking you to complete the square for this quadratic equation. Obviously, we're going to need the coordinates of the maximum or minimum point for the next part of your sketching the graph. Okay, that's why we always do this part first. Completing the square for the top part, 5x squared minus 14 over 5x minus 3 over 5. Okay, then from here, 5, complete the square on the quadratic equation inside, x minus 14 over 5 divided by 2, 14 over 10 square minus 14 over 10 square minus 3 over 5. Okay, then from here, simplify the bracket, you would have ended up with x minus 14 over 10 minus 14 over 10 square negative. So that's times 5. Minus 564. 64 over 5. Okay. Now we know that if we were to plot this graph, the minimum point would now be at 14, 10, and 64 over 5. All right. From here, we're going to sketch the graph that is the modulus of the quadratic equation that we just did. Now, again, to sketch the graph of the modulus, you're going to need the intercepting points for the x-axis, right? So we're going to need to solve the quadratic equation, 14 minus 3, where x would actually equals to negative 1 over 5, or x would equals to 3. Okay, then having all these points now, we can actually we can sketch our graph properly. Let's say 1 over 5 is here, negative 1 over 5. Let's say 3 is here, and it intersects at the negative 3 value, which means since it is a modulus, would intersect at the positive 3 value. Okay, then finally sketch our graph. It's going to look something like this and bounce off. Then they would have a minimum point of 14 over 10 and 64 over 5. All right, maximum point, and curve back down, and then curve back up like so. Okay, and that would be the sketch for this question here. Then lastly, looking at the final part of the question, state the values of k for which the modulus of k here has exactly 4 solutions. Looking at your graph again, the only part that would have 4 solutions would be everything here, 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 okay? And anything in between your tangent line here and your value of x equals to, when y equals to 0 line here. Okay? So since we have the coordinates already, we can already determine that everything in between these 2 limits are the values of k for which you have 4 solutions. See, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, so on and so forth for everything in between here and here. Okay, So in this case, it's going to be an inequality, just like the question from before. K has got to be in between 0 and 64 over 5, which is 12 and 4 over 5. Okay? That would be the values that would have 4 solutions in this case here. Looking at one more example, in this case here, this is actually a cubic graph because why? You have 3 brackets, okay? And in fact, it is a negative cubic graph. That means it will start from this end and end at this end here, okay? So firstly, we identify the values where it cuts the x-axis. It's going to be when x equals to -2, when x equals to 1, and when x equals to 6, okay? Sketch them, plot them onto the graph here, where you have 2, 1, and 6 somewhere here. -2, sorry, okay? And one more thing that we need to know is, what would the y-intercept be? For us to do that, all we have to do is multiply the numbers here, 2 times -1 times -6, and then this value times the negative value here. Okay? Then you would end up having -2 times -6, positive 12 times negative, so you have -12. Okay? And that would be somewhere here, -12. Okay? So from these points that we've already identified, we can already sketch the graph of the cubic equation, which will look something like this. Oh boy, maybe I've put that a bit too far. Yeah, put -12 somewhere closer here. Okay, 6, and then it will actually look something like this. Okay. Something like that. As long as it starts at this end, ends at this end, and has the curves on this and this side of the quadrants, you should be fine. And obviously, you have to draw it as smoothly as you possibly can. And as for this last part here, hence solve for the cubic equation graph that you just drawn, where the values is less than 0. Now, if you were to be very strict about where 0 line is, then the 0 line is from here. Everything less than 0 would be the values here and here. Okay, so our two inequalities are going to be when x is in between +1 and -2, you see, from +1 to -2, or when x is more than the value 6, then these are the times when the values are less than 0. Okay, hope you find this video helpful. Thank you.